Now that we know how to write the formulas for a lot of ionic compounds, it's going to be important that we go back and learn how to name them. Now remember, we're really just focusing on binary ionic compounds here. That means a compound made of two simple ions. All right, so let's take a look at first our cations. We're going to need to know how to name our cations before we move forward. Cations usually come in two flavors, those that we call the regular metals and those that we call the transition metals. Now, to be very, very clear, regular metals we're going to include any metal in the alkali metals, the alkaline earth metals, silver, cadmium, zinc, and aluminum. Transition metals are going to be classified as absolutely everything else. So I've found it's actually pretty helpful to label these on a periodic table. So it's the first two columns and then this little zigzag down from aluminum of these four little atoms, aluminum, zinc, cadmium, and silver. Those are all what we're going to consider to be the regular metals. Now, our transition metals, if you can just kind of imagine that that's about where the staircase is, everything to the left of that staircase is going to be considered to be a transition metal for the nomenclature part of this. So again, one more time, regular metals are alkaline metals, the alkaline earth metals, silver, cadmium, zinc, and aluminum. Transition metals are everything else. Now, why are these in two different groups? Well, regular metals have a very consistent, predictable charge on the periodic table, whereas transition metals do not. They have a variable charge. So we're going to have to handle them separately as we go to name them. Now, we had a little bit of a sneak preview of this already. So for example, if I wanted to say sodium as an ion, I would just say sodium ion. Because it always has the same charge, it's not important to include that as part of its name. Whereas the transition metals, when they become ions, because they have a variable charge, I want to be very specific about which charge I'm dealing with. So that does need to be included as part of the name. So if I wanted to say copper with a 2+ charge as an ion, I would say copper with a Roman numeral 2 ion. That's how we name our cations. Now, luckily, naming anions is a lot easier. Negative ions always have a predictable charge. You can look them up on the periodic table and always know what they are. So the charge does not need to be included with the name, and there's not multiple groups of different types of anions. Very straightforward. So we're just going to name them. Here's a couple examples. O2-, P3-, and N3-. Notice that all three of these things have two things in common. The name of the atom has changed. So instead of oxygen, it's now oxide. Instead of phosphorus, it's now phosphide. Instead of nitrogen, it's now nitride. So the ending of the element, we need to chop off the old ending and add IDE. And the last and most important part, of course, is to call it an ion. All right, time to bring our two halves together. Let's name an ionic compound. Let's start with something familiar, NaCl. When we start to name ionic compounds, we want to name both ions separately, and then just like we form an ionic compound, we'll bring the two names together and clean it up a little bit. So first, I see that we have Na. Na is just a regular, plain, old, normal cation. So I'm going to call him sodium ion. And chlorine as an ion is just called chloride ion. I'm going to go ahead and write both of those items down, sodium ion and chloride ion. Now, that's a lot of words. When we bring those two ions together to form a compound, they're no longer two separate ions, they're an ionic compound. So I'm going to remove the words ion. And what I'm left with is its compound name, sodium chloride. Let's take a look at another example, MgCl. Again, you can name each ion separately and then bring the names together. Mg, regular metal, magnesium ion. Chlorine, chloride ion. Write the two names down, take away the ion parts, and you have your ionic compound name, magnesium chloride. How about something a little bit more complicated? CuCl2. Now, you might be wondering, well, why is this complicated? Well, take a look at the metal in the front. Is that a regular metal? No, it's not. That's a transition metal. And when we name those ions, we do need to include the charge. You might be wondering, well, where is that charge? Well, I'm about to show you. Let's write down at least what we know right now. We know eventually this is going to be called copper, and then at the end, I'm going to say chloride. So I'm going to write that part down. But after the copper and before the chlorine, I need to have a little Roman numeral right there, which indicates which form of copper I'm using, what charge belongs to that copper. Well, you may remember that when we formed the compound in the first place, we used this crisscross method to try and get the charge in the right spot. We can use an uncrisscross method to get that charge back. So if I just simply uncrisscross my numbers, I should be able to figure out what charge that copper originally had. In this case, yes, you'd be dealing with copper 2+. But before you just go jotting that number down, it's important to double check. Always double check that we uncrisscrossed the correct charge to the always 100% predictable anion. Chlorine, we look it up on the periodic table and make sure that it makes sense that it has -1 charge. And in fact, it does. So I can believe my +2 on my copper and go ahead and add that to the name. The final name here is copper 2 chloride. I think you could probably benefit from maybe another example like this. So let's take a look at one more, CuO. Okay, so first step, we know that it's going to be called copper, and we know that it's going to be called oxide. Now, if it would be a regular metal, we'd be done, but it's not. It's a transition metal, and I need to include that Roman numeral with its charge. So let's get started. Copper and oxide. I want to make sure I'm ready for that lovely little Roman numeral. So I know that's no good. I got to keep going. Let's start by uncrisscrossing. So in this case, if there's no numbers, no number indicates a 1. Let's uncrisscross our 1s back. So I would end up with a Cu with a +1 charge and an O with a -1 charge. Now, before you go jotting down the answer, let's double check it one more time. Always check the anion. Does it make sense that oxygen has a -1 charge? No, it doesn't have a -1 charge. We took a look on the periodic table. It's supposed to have a -2. So to correct it, you can multiply it by a factor of 2, but multiply everything by that factor of 2. So both copper and oxygen here must have had 2 charges. That's something worthy of writing down. Copper 2 oxide. Again, if that anion is lying to you about its charge, we have to correct it. Multiply that common factor that we would have eliminated before back in. Now, this method might be confusing to you, so I do have a quick alternative method that some students do find a little bit simpler. Let's take a look at this example. Again, I would love to say tin for the SN and oxide for the oxygen, but it's not going to be that simple. Tin here is not marked as being one of our regular metals. We need to include the Roman numeral with the charge. Instead of uncrisscrossing this time, I'm going to do something different. I'm just going to simply start by looking up the charge of the oxygen. Again, the anion will always give you a nice, easy, predictable charge that you can always believe. So I'm going to write that down. Then I'm going to multiply it by its subscript. So 2 times 2 is 4. Then I'm going to divide the subscript out for the tin. Now again, there's no number there. It's a 1. So 4 divided by 1 is 4. So the charge of the tin here must have been a +4. Now I can go ahead and finish up my name. Let's translate that 4 into a Roman numeral. And now I can simply name the tin and the oxide. So tin 4 oxide would be the name of this compound. Again, I think you need one more quick example. So here's another one. Cr2S3. I'd love to say that the name of this guy is chromium sulfide, but that would not be correct. Chromium is a transition metal and it needs that Roman numeral. So let's start off by looking up the charge of that anion. The charge of the sulfur is 2 minus. So I'm going to take 2 times its subscript 3 and get 6. Then divide out the subscript for the chromium. 6 divided by 2 is 3. So 3 must have been the charge of the chromium. Now I can translate this into a name. So 3 as a Roman numeral is just 3 little lines. In front of it, I can say chromium, and behind it, I can say sulfide.